Howdy, my name is Mech. I run openlibrary.org with Drini and a bunch of other folks from the Open Library community. Today I'm going to be giving a quick tour of the architecture of Open Library and also the code layout. So the first thing that you can see is I'm in the Git repository for Open Library. From the command line. If this view is not to your liking, we can also just go directly onto github.com/internet archive/open library, and we're seeing the same file layout here. On the GitHub, the README does a pretty good job of explaining some of the elements of the front end and the back end, the code organization here in terms of the different directories that are available and what they do. Also how to use Docker. So if you go back to the main README and you navigate over to the installation section, the installation has a video tutorial on getting set up with Docker, and then also a set of instructions that you can follow, and it's more or less step by step. And if you have trouble with the Docker installation or the Docker setup, then you can just go into issues, and once you click issues, you can either search for a Docker-related issue that might have been hit in the past. Here are a few that are open, so you can take a look at those and see if any match, or you can click on closed. And these are oftentimes issues that have been resolved, and so the fix might already be documented for you. Okay. In addition to the main wiki page, which is a great source of information, this main README, sorry, we also do have a wiki. And let's see if I can get to it from here. This might not be what I want. Nope. So if I scroll all the way up to the top here and I click on wiki, the wiki is going to provide me with a portal of information, both about our community, how we communicate, the different team members. So if you wanted to contribute to a specific portion of the code, such as Python 3 migration or maybe the book sponsorship program, then you can go to Christian Klaus or Tabish, respectively, and ask them for help. But what we want to look at is under our administration, systems, and DevOps, there's a specific section for production architecture and provisioning. And this is for someone who just wants a really high-level bird's eye view of what makes Open Library run. And the general idea is when someone goes to openlibrary.org and they press enter, like I just did, the website renders. And as that process is happening, what's actually happening is a user comes in to a virtual machine called OLWWW1. WWW1 has Nginx and HA proxy that both live on it. Nginx is the first thing to intercept the request. It does things like SSL termination, and then it passes the request over to HA proxy, which is a load balancing tool. In fact, I think if I go to maybe openlibrary.org/status, is that what I want? No. Here, we'll quickly go. If you go to openlibrary.org/admin?stats, then you can see our dashboard for HA proxy. Now, the purpose of HA proxy is if you have a lot of traffic to one of your servers and or more traffic than can be accommodated by a single server, then, for instance, you can use HA proxy to receive all of the incoming requests and then balance the load by transferring the signal to another VM or another machine. So in this case, if we go back to our diagram, we come in on www1, Nginx receives it, it forwards it to HA proxy, and here's HA proxy in real time. You can see that HA proxy, when it receives a request, it sends on the signal to either OL Web 3 or OL Web 4. And Web 3 and Web 4 are the two servers that actually run the Open Library web service. So here we are on the diagram, Web 3 and Web 4. And that's these three machines are a part of the core of the system. In addition, when a request is made to Web3 or Web4 and it fetches data from the database, which is this Postgres instance that you can see over here, DB1, which is backed up via replication on a second server called DB2. When OL Web3 or Web4 have to access a database record, oftentimes the database record will be cached in memcached. And we have three different instances of memcache here. It used to be 0, 1, and 2. I think it might now be 2, 3, and 4. It's a small detail. It doesn't really matter. And then the next time OL Web3 or Web4 request the same record, oftentimes it will be fetched directly from memcached in RAM, which will be a lot faster. Now, there's also two other services here that are critical. One is Solr, which is when you go to openlibrary.org and you type in title, for instance, as an example search, then all of these records are being returned by our search engine, which lives on OL Solr 2. You'll notice that there's this thing called OL Home here, and that's because OpenLibrary runs a piece of software called Infogami, which has a core called Infobase. That's this IB here. And oftentimes when Web3 or Web4 are accessing an open library record, when I say open library record, I oftentimes mean an author, a work, a book, or an edition. There are some other types as well, which I believe you can go to openlibrary.org/type, maybe? Let's see. So here's an enumeration of the different types that exist in our Infogami system. Editions and works are two types. An edition is a specific version of a book. So let me click on a book here. This is an edition page. We're seeing that the URL is book/. We can see that it has an ISBN. This is a specific version of this book. However, this same book may have been published in, who knows, 1987, 1988. There could be tons of different republications of this book. And if I click on the 51 editions here, you'll see that the URL changes to a work page. And here on the work page, there's an enumeration of all of the different editions that we have. And so both of those are examples of types that appear in the Open Library, the corpus of different things or types or records, which is openlibrary.org/type. So whenever we try to access a record, what happens is a user lands on openlibrary.org, that goes to OLWWW1, that gets forwarded to either Web3 or Web4. And from here, if we're accessing a database record, that goes through Infobase, which is running on a service called, or running on a VM called OL Home. And Infobase talks to the database, or it talks to memcached, depending on whether we've already accessed this record recently and it's cached, or whether we need to fetch it directly from the database. And sometimes, if a user is doing a search, OL Web3 or OL Web4 will hit OL Solr. There's another small case here where when we're accessing book covers, that's done on this dedicated book cover service called OL Covers One. And that is the basic overview of the production architecture of the production service architecture of Open Library. Let's jump to the second part of this introduction, which will be the code of openlibrary.org. And I believe if we look through the documentation here, there is an overview of all of the endpoints that exist on Open Library. This isn't completely up to date, but if we scroll down here, we see a list of various endpoints from a URL perspective. For instance, if I go to openlibrary.org/books.json, then this endpoint, this .json endpoint, should be included in our documentation here. And if we keep scrolling down, we can see more of a comprehensive list of what all of the endpoints are, as well as the URL, or as well as the model or the routing that is responsible for capturing a request and generating the result, the views. And so we can scroll through here. So that's a great place to start. Some of these are a little out of date, so that would be a great first issue if you want to take a look at which of these paths are no longer current and help update this documentation. That would be a big help for developers. Under the front-end documentation, which is also listed in our wiki here, we should see a pretty good description of how the front end works and how developers can contribute. Again, it's talking about the infogami types here, which I just showed off in the openlibrary.org/type endpoint. That's what these infogami types are. We talk a little bit about working with JavaScript, which I'll go into when I actually jump into the code. We talk about working with Docker if you're on the front end. So if you make a change, how do you get that reflected in your application using Docker? And some things on internationalization. Not exactly the thing that I'm looking for. The routing. So this is actually a useful snippet. This talks more or less about what I've already been saying in terms of how is a request processed by OpenLibrary, how does the URL routing work, and I can talk about that in a little bit more detail. But this is probably a good time for us to jump into the code itself. And so if we go back to the GitHub landing page for OpenLibrary, almost all of the code that we care about is going to be in the OpenLibrary subdirectory. And so other than the static directory, static is where our images, our static assets live. That's our images, our JavaScript prior to, or at least our vendor library JavaScript like jQuery, things that we are not, things that are third-party libraries. So why don't I just jump in to be a little more comprehensive. Our CSS or less is located in the static directory. We have fonts, images, and it looks like we've actually moved our JavaScript out of this directory. So these are just static assets. And if we look in CSS, we can see all of our different components. This is the place that you're going to want to look for different CSS assets, like our buttons, for instance. So I'm going to go back up to the main directory here, having gotten the static assets out of the way. The next thing that we're going to do is jump into the OpenLibrary core directory. And within the OpenLibrary core directory, the majority of the files that you are going to care about are either in core. I would say core is the location where many of the models are kept. Within core, we'll see more API level, core API level things, such as if we're making a request to archive.org for resources, that will probably happen in here. In fact, it'll happen in this IA file within core. And so you can look here, and this is, for instance, how we can fetch metadata from archive.org. And that's if I go to archive.org/details/the geometry. This is an example of an item on archive.org. Archive.org is the website where our books are actually stored. Here's an example of one of those books. If I change the URL from the human readable details page and I change details, the word details, so that it's metadata, then you can see, oops, sorry, I don't want this other stuff on the end of the URL. If I just go to metadata/the geometry, then I get this JSON representation of the item. It has a lot of rich information about the files of the book that don't exist on OpenLibrary. So openlibrary.org and archive.org operate in synergy with each other. And so this is an example right here, openlibrary/core/ia.py, of how OpenLibrary gets some of that metadata from archive.org. I'm going to go back. We also have some loan stats. Some models is probably the core one that you'll care about. There's also how book ratings are done, how bookshelves are done, some wrappers for our database. But the most important one probably is going to be we have book sponsorship here. Vendor.py is where we fetch things like price information from our friendly partner vendors. And then the most important one is this models.py, which really enumerates the core models for Open Library. If we scroll down, we see images such as book covers. We see a model for works and all of the properties and class methods or instance methods that you can call for a work. We have editions here. We have authors and all the members of authors. You can get an authors list. Users, so you and I would be patrons or users on Open Library, and you can get all sorts of interesting things like our preferences for the website. You can save our preferences. So most of our models are in core models. Now I say most because there's one exception, or one big exception, and that's if I go up a directory back to the kind of the core of Open Library here, then outside of core models, the other directory that we really care about is plugins. And if we enter plugins, we're going to see a few different directories. Most of them are not going to be important for what we're working on. I'd say the 3 that are going to be the most important to us, almost all of them are going to be irrelevant other than the Open Library directory, which has a lot of our API definitions, the route mappings for our APIs. It has the homepage generation and several other scripts. We could actually take a look in here. So are any of them going to be important? No, I think really the homepage is important. And the other thing that will be very important is this API.py, which is where the definitions for our APIs are, such as like the book availability is defined. Here's the get and the post for book availability. If we keep scrolling down, we have our book ratings APIs listed in here. Bookshelves, that's like the want to read button. When you click want to read or already read, then all of that is using this API endpoint, the bookshelves. There's the ability to fetch all of the editions of a work. Author works, that's what are all the works, the books that have been written by or authored by an author. So these are the APIs, or a handful of the APIs. We're going to jump back a directory here. So as I mentioned, the home.py is the file that generates all of the information for our homepage. The API file has all of our API definitions. Code.py is more or less the plugin that it's the for lack of better words, the master plugin that initializes all of the other plugins. And we can take a look there. Chances are we're not going to really need to play with this file all that much. But you can see way at the bottom here, we have this setup, which is initializing all of these other plugins in the Open Library directory. So we've gone over home.py, api.py, code.py. I think we probably want to do this differently in the future, but if you are dealing with any of our JavaScript is also in this directory. So if I click JS here, that's Open Library plugins, Open Library JS. JS is where all of our our JavaScript lives. So not necessarily our third-party libraries, although I think many of those are in here now as well. And the main entry point is this ol.js. So that's a great place if you're lost in JS land, in JavaScript land. ol.js is a great place to click around, and you can see the initialization, what happens. This deals with a lot of our homepage search functionality. This is a good place to start. And when you want to remake your JavaScript, if we go back all the way to the root of the project here, all the way to the root, there's this make file, which I can click on. And if we were to run make.js, then this make.js will take all of the files from that Open Library plugins JavaScript directory that we were just in, and it will do all of the transpiling or minification and ultimately generate the workable JavaScript for your project. And the same for make CSS, I believe, yes. This will take all of our less and basically compile it down, pre-process it down and compile it into a CSS file that we can use. So those are a few of our plugins. Let's go back into plugins because I mentioned there are a few plugin directories that are important. Open Library, which we're now back into, is the first plugin, and that has some APIs. It has the home page. It has a lot of our JavaScript. Those are some of the more important things that you'll likely be doing in this directory. The other important one is work search, which is if you are dealing with Solr and you're dealing with anything that has to do with the data modeling for our search experience on the website. For instance, if I type Lord of the Rings, this is performing a work search, and this plugin directory, work search, has, I should probably also mention that every one of these directories, thanks for letting me skip around here, every one of these directories, such as Open Library, Upstream, Work Search, are directories of plugins. And each directory has a code.py, which is responsible for registering every other plugin in that directory. We saw this as an example for Open Library. When we click Open Library, we noticed there's a code.py. And at the very bottom of code.py, you can see that it instantiates the plugin for our homepage, for some of our stats, for some of our events, for our authors, information like that. And so for work search, if we treat that as a second example here, the work search plugin collection has a code.py, just like Open Library does. And if we scroll to the bottom of this file, we're similarly going to see that the work search plugin collection instantiates a subjects plugin, and also a publishers and a languages plugin. And also the core, it imports whatever modules it needs. All right. In addition to, in code.py, we also see a lot of the logic for performing searches on Open Library. And there's not enough time for me to go through everything here. However, if you can kind of work your way back of looking in the search HTML template, which I'll show you later, and you can see what functions are being called from the models. Then you can go into this file, and you can see things like, here's a perfect example, running a Solr query. And Solr, as we showed earlier, was one of our VMs. That Solr is our search engine that we use for conducting searches for authors or works or editions or whatever it might be. And so here's the logic for running one of our queries, and this ultimately returns the search results that we saw here. Okay. So that's probably all you need to know about the work search plugin collection. Code.py has most of the things you need for search. We're going to go back to plugins here. So now we've gone over Open Library, which has the home page. It has the where our JavaScript lives. We've gone over work search, which is where our search infrastructure lives for finding works on Open Library. And then I'd say the other one that's going to be relevant to most people is this upstream. Import API is where our book import endpoints are. So chances are you're only going to need to jump into this plugin if you're dealing with an import bot or some other import process dealing with core catalog metadata. So if you're going to be importing new books in bulk into Open Library or trying to fix an element of our import pipeline, this is a good place to start. And then also in the core of Open Library, there's a directory called catalog. And catalog has all of the import code, such as within add book, init.py, there's a function called load. And this is the real meat and potatoes, or the real core of our import process. And Charles Horn, who's Horn C on GitHub, would be a good person to ask questions to if you have a question about how this importing code works. Let me go back though, because the import API routes are likely not going to be relevant to most people who are working on the front end or a good first issue. So we've looked at work search, we've looked at the Open Library plugin, we've looked at, or at least talked about, the import API. The majority of the other plugins are not going to be relevant to most people, except for Upstream. Upstream has a few essential components, and one of them is related to one of the first files that we opened, which was in, if you remember, let me open up a new tab so I can switch quickly between the two files that I'm going to show you. One of them was the core directory. Now, core was way up on the same level as plugins, right? So here's plugins, which is where Open Library and Work Search and Import API and Upstream live. And then there was core, and core had this file called models.py, which defined most of the models for Open Library, such as works. So let me go up. So this defines what a work is on Open Library. Well, when we're actually in an HTML template working with a work or an author or an edition, then the upstream plugin class, or plugin collection, I think is more appropriate, has its own, it's somewhat confusing, it should probably be refactored, but has its own models.py, right? So I'm going to click that. It's confusing because if we scroll up here, we're going to see that Open Library core models has a definition of work class, but also the Open Library plugins upstream models has a definition for the class work. And I think a good rule of thumb is that the upstream models.py is built on top of and over core models, and it actually extends it and adds more logic into it. So in fact, if we look at Open Library core models, and we can see at the bottom where all of those models are kind of registered and mapped to Open Library, which is actually something that I want to talk about in just a minute. So let me save my place there. We can see that this work class extends models.work. And this other file, this core models, is the models that it's talking about. So this is, when you're in an HTML template, which we're going to look at next, and you see a work, all of these methods are methods that exist on that work. Now, one thing that's going to be very confusing is when I go to openlibrary.org slash, let's choose a book page. This is just a book that I happen to have in my URL history. So I'm going to press enter. Then this is a page, again, for an edition. And this edition, what happens when, I'll go all the way from scratch here. When I go to openlibrary.org slash books slash the ID, the first thing it does is it sends me into OL www1, which is Nginx, and HA proxy, the load balancer. It decides whether to send me to OL web 3 or OL web 4, which we saw the load balancing happening right here. And then once I'm in either web 3 or web 4, it will pass my URL request to the Open Library application itself. And so that's where, when we were on the GitHub wiki, we saw a list of all of these an enumeration of the endpoints. So I'm going to scroll all the way down here. And so for books, for instance, or you'll see a lot of mappings between URLs that we define, such as this one, and the code that answers the call. Maybe an example would be useful here. So I mentioned the home page earlier. Let me just go back to the core here on Open Library. On Open Library, if I go into plugins, which is where most of our routing is defined, then I can say, what serves the home page? And here I see that the Open Library homepage is served by Open Library /plugins. So we know it's a plugin. As you can see here, a ton of things are plugins. Most URLs are defined within, the routing is defined within the respective plugin. In this case, the plugin is Open Library home.py. So I'm going to then, so this was my first step, is look at this wiki of endpoints. Then the next thing I'm going to do is look in the code. We're going to go into the plugins directory, which is in Open Library plugins. Within Open Library. And we're going to find home.py, which is what the wiki document told us to navigate to. And then if I scroll down, we're going to see something that looks like class home. Extends delegate.page. You don't have to really worry about that, but this is a hint. Whenever you see delegate.page, that's a hint that this class is defining routing. In this case, the route that is defining is /, which is our homepage. And we can see that a get method, which is like an HTTP get, is defined. And so this class is responsible for listening to a request to openlibrary.org /, which is our homepage. And when a GET request is made to that URL, it will return the template for the homepage. That's what you're seeing right here is WebPy, which is the web framework that we're using for Open Library, has the ability to render an HTML template. And we can see here that let's just follow the logic here. So web.template is rendering this thing called cached homepage. Cached homepage comes from a function call to get the cached homepage. Here we see the function of get the cached homepage. The get cached homepage returns a cached version of this function, get homepage. We scroll up just a little bit and we see we've finally gotten down to the bottom. Here's where the homepage is rendered. We see a little bit of logic here. We want to get all the blog posts because the blog posts are displayed on the homepage. Let me just prove that to you. We go to the homepage, we scroll all the way down. We see some stats here, right? These are stats. And then we see some blog posts. Okay, great. Well, here are the blog posts. Here are the stats. And what's ultimately happening here is we render the page. And we do that by getting the template, which is in our templates directory. I'll show you that next. And within the templates directory, there's a file called home/index.html. And the way to interpret this line is that we're going to render a template in the templates home index directory, or sorry, it's templates/home/index.html. And this is the information that we're going to pass to it. We're going to pass it stats, and we're going to pass it the blog posts. And why don't we actually jump into the template here? We're skipping ahead. Templates are at the same level as the core models, the same level as our plugins, and here they are, templates. So if we click on templates, we see an organized collection of different templates. One of them is home, right here. So I'm going to go into home. So now we're in templates, home, and then index.html is the file that we are rendering right here. And you'll notice that the first line has this thing called def with. This is basically saying define the template that we're in to take these different pieces of data or parameters. And this is how we're sending the stats in. This is how we're sending the blog posts in. So I'm going to go back a tab. This is the plugin for the homepage, if you recall. And we went through that whole trace of first the user goes to www1, Nginx goes to HA proxy goes to Web3 or Web4. The Python application, the web services run on Web3 or Web4. The plugins, which are all registered, listen or add a listener for anyone who types just openlibrary.org/, which is a homepage. This class captures any GET request to the homepage. We perform a function call to get the homepage, which then renders template/home/index.html and sends in the stats and the blog posts, which is this other file. And then this template accepts stats and blog posts, and then it renders a bunch of carousels, which are the themed carousels that we see on the homepage, just like these. These are the carousels. There's one carousel, one carousel, one carousel. That's what we're seeing. That's all of these custom carousels. And that's how a template is returned up. And so if you wanted to work on the HTML or fix the templates, this template directory is where all of the view level templates are stored. The things that listen for the URLs, the routing, and the routing definitions are all in plugins. And basically how it works is the templates are the thing rendered within the plugins, and the plugins get all of their data from either the plugin models or the core models. And that's the high level architecture here. One thing that I did want to share, I'm jumping back into our core models. All the way at the bottom here, we see a few registered models. And this is going to trip people up because you'll notice that works, editions, authors, users, lists, etc. are special type of types where there isn't a URL defined in our code. What I mean by that is if we go back here to our list of routing, I'm going to go to the wiki. The wiki has the endpoints. We will not find an endpoint for /works or in the wrong file. I am. My apologies. We want the overview of HTTP endpoints. So we will not see /works or on this right-hand column or /books because these are they're magically generated by this registration. What this registration right here means, right down here, is when a patron, when a user goes to openlibrary.org/authors then we're automatically going to go into a special templates type directory. Let me go there now. So we're going to go to Open Library. We're going to go to, so now we're at the level where we see core, where we see plugins, where we see templates. I'm going to go into the templates directory, and there is a special directory here called type. And within type, we're going to see all of our registered types. We're going to see our authors. We're going to see our editions. We're going to see our work. And whenever we go to openlibrary.org/books, or whenever we go to openlibrary.org/works, sorry, not .json, works, or anytime we go to openlibrary.org/authors, then each of these pages doesn't have a URL endpoint. What happens is there's a special model that notices we're typing the URL for one of these special classes, and it automatically fetches the corresponding record from Infobase, from the database. So it fetches the author, or it fetches the work, or it fetches the edition, and then it passes that edition in to the appropriate work, author, or edition, for instance, templates. And that happens, let me find where I was. Let me kill some of these tabs. That happens within this Open Library templates type directory. So if you are completely baffled and wondering where I'm trying to find the routing for the editions page, it just doesn't exist. It's all dynamic. The best you can do is either change the plugin models, the Open Library, the plugins upstream models.py. You can change what properties actually come through on the work or the edition or the author, or you can change the template, and the template is an Open Library templates type. And as an example, we can go into edition. By default, every type has the same structure. All of them have a view.html. That's just how it works. So a work, an edition, an author, all of those types will live in templates, type, edition, and then view.html, or in work, there's a view.html, or an authors, right up here, has a view HTML. And if you click on the view HTML for authors, this is the authors page. This is openlibrary.org/authors, yada, yada, yada. This renders, this author page for Tom Clancy is being rendered by this view within templates type author. Okay, so that's pretty much all we need to know now about core models. Core models is what defines not only our Open Library models, but also what registers our special types. And now we can pop the stack and go all the way back to our final set of plugins here. So we've talked about core, which is where all of the models live, all of the data live, the data accessors live, database fetching. We have the plugins, which is where all of our non-special URL handling is done, and where all of the gets and the posts and routing are defined. So the routing, the plugins either fetch the models and then generate data and then return templates, or we skip the plugins and the core models kind of return their own templates using that core models register logic that I just showed you. So there's a few other files that you'll probably just discover as you need them, like accounts and borrowing, etc. But that's probably not going to be very relevant to many of the first Git issues. So let's end our tour here in Open Library plugins upstream. Remember, we talked about a few plugins that were useful to newer contributors. One of them was Open Library, which is where the JavaScript is. One of them was the Work Search, which is where our search engine, our searching Solr logic lives. We mentioned briefly Import API for anyone who's dealing with our catalog system. And we also mentioned that the other half, the actual models that go to this plugin, are in Open Library Catalog, Add Book. But the last section we want to look in is upstream, and we already looked at the upstream, the plugins model, the plugins upstream models, which has the models that extend core.models. These are kind of like the super models that get passed into the template. Right. I think that's what I wanted to show is if I, in a new tab, again, thanks for bearing with me. There's a lot to cover here. If we go into templates and we look at our special templates, which are in the type directory, and we look specifically on the edition type, and we go to the main HTML file for editions, which is view.html, then we see some slightly different parameters getting passed into the template definition. The first parameter is page. And almost every magic template, the first argument is going to be page. And in this case, page is the model. So in this case, for the edition template, page is an edition as is defined by Open Library plugins upstream models.py and then the class edition. So for instance, this get authors of edition, we will see in the edition template as accessed by page. So we'll probably see page.get authors, and there it is, right? So that's just proof that the page that's automatically getting, the page object that's getting passed into this template is defined within the core models. And the same is true for if we weren't dealing with the magic edition templates and instead we wanted to deal with authors. So I go into the author view.html. Now the page that's getting passed in is now an author. So if we go back to our plugins upstream models and we look for the class author, we can see that the author has get photos, get books, get work count, and some of that we might see in the template. Get photos, there's get photo URL. Yeah. Okay, so that is how Open Library works at a glance. We talked about the infrastructure, the provisioning of Open Library, meaning the different production VMs that all work together to make the Open Library service possible, and that's Web 1, www1, that's Web 3 and Web 4, which are the web service runners. There's Solr, which is our search engine. There's Memcached, which are doing all of our caching. There's DB1, which is our primary database, Postgres, and DB2, which is a replica. There's the cover store, which serves all of our book covers. And then there's this thing called OL Home, which runs Infobase. It's kind of a connection between Web 3, Web 4, and also the database. We talked about how where the static files live for Open Library, and we said that's in two different directories. One of them is at the top level within static. This is where the CSS and the less live, also images, fonts, etc. Also, the JavaScript is not in static, it's in Open Library, then it's within the plugins, and then within Open Library, then there's a JS directory. And here we can see all the JavaScript files. Again, ol.js is the entry point, And when we want to rebuild our JS, we're going to go again to the top level here. There's a make file, and that make file has a make.js defined and a make CSS. I think there's also a make all, which regenerates our internationalization, and also does our CSS and JavaScript. Great. We talked about the three main kind of like model view controller setup here, which is that within the Open Library project, there is the core models, which has models.py. There is the plugins, which defines the kind of the controllers and generates, views. And then we have the templates, which are ultimately the thing that's oftentimes getting rendered up by the controllers or our routing. And so again, the plugins are either going to be magical plugins defined by this core models. And the two things that are special there is they don't have routing. They automatically get turned into a page object that then gets passed into the templates type views. And then we have the other templates, which are the ones that we define. And in those cases, the plugins will define an endpoint for get and post. The user will go through that whole www1 to web3 or web4, yada, yada. And then the correct router and plugins will get the request, will generate the right template or API result, and then return it back to the user and possibly cache it. And that is a not so gentle introduction on the Open Library code base. If you do have questions, the wiki is a great place to start. You can also email us at either mek@archive.org or Drini, DRINI, @archive.org. And we would be happy to walk you through anything that you're stuck on or invite you to our Slack channel. Before joining our Slack channel, I would definitely check out the Docker setup on our homepage for on Internet Archive Open Library GitHub. Check out the Docker instructions, try to get your development environment running, and then let us know if you have any questions. This has been a blast. Thank you so much for taking the time to listen, and thanks for your contributions to Open Library.